She was making a joke. Way to ruin it.
Precious.
Sorry.
Oh, yes. Okay. So we have this style called inductive reasoning. Well, first, let me put my name on here. Because we always put our name on top of our papers, right? Okay?
Costco.
Oh, I think you forgot how to spell your name.
Hey, inductive reasoning. This is one of our methods that we're going to use to think. This is going to be one of our methods we use to think and approach things, okay? So inductive reasoning is making a conclusion based on observations
Oh my god.
and patterns.
I'm getting it.
I thought you asked crazy. Next time do not throw it, please. So it's making a conclusion based on observations and patterns.
Can I?
Conjecture. A concluding statement
I can't. I'm sitting on the floor. Sorry.
a concluding statement reached using inductive reasoning.
Mr. Castle,
Yes.
I don't know if you've realized it, but I have very bad vision. I can't see.
Amy, you want to move up to this spot next to the today?
Is it a concluding statement?
Reached using inductive reasoning. Ian, do you have pair glasses?
Yeah, but they're currently broken.
So inductive reasoning is pretty much just observation.
Yeah, so let me explain this a little more, okay? So inductive reasoning is using observations and patterns to make a conclusion. Conjecture is the conclusion itself. So you use inductive reasoning to make a conjecture or a conclusion. So for example, in like elementary school, okay, you lined up to go to lunch, right? Okay? Now let's say the teacher lined you up, boy, girl, boy, girl, boy, girl. What do you think would come next? Boy, right? Okay? That's using inductive reasoning. You said, hey, there's a pattern here. It's alternating boy, girl, boy, girl. So the next one would probably be the opposite one of what was before, right? That's using inductive reasoning. And your conjecture is that, oh, the next one would be a, what did I say, girl? Boy? Next one would be a boy. I forgot which one it started with. Next one would be a boy, okay? So that would be your conjecture from that. That's using inductive reasoning. Or, for example, here, the stripes on the flag. We say it goes red, white, red, white, red, white. What's going to come next? Red. Okay, we're using our inductive reasoning. We're using the pattern and observation that we see to say, hey, this is what I think is going to come next, okay? Or like in our notes, okay, last chapter we had section 1.1, then we had 1.2, 1.3. Our observation and pattern tells us that our conjecture should be, oh, 1.4 is going to be next, then 1.5. We're going to go in order, okay? Hopefully that makes a little more sense that way. We're going to go through some examples of this, and I think this will help, okay? So our first example, we're supposed to find the next 5 terms of the sequences, then write a conjecture. A sequence is just a series of numbers, okay? It's just a series of numbers, or terms in this case. So we call these terms. So it's not like a like term, like in algebra. Don't write this down. But it's not like 2x plus 7, where these are different terms, or where 2x plus 3x are like terms, okay? It's a little bit different. Each one of these separated by a comma is a different term. So this is the first term, second term, third term, fourth term. What do we see that's happening in number 1, Gracie?
It's going down by 7.
It's going down by 7. From 38 to 31, we're subtracting 7. From 31 to 24, we're subtracting 7. 24 to 7, we're subtracting 7.
I don't
So is
understand
this-
how you can just know that. No, I had to actually look at the Okay, well when I looked at it, I was like, what?
I had to.
And
To think.
And I'm gonna bring that up in a moment here, okay? Because some of these are easier to see for some than others. For example, last class I was going through this with, okay, just earlier today, and what happened is that like the first three, some different people got them like right away, but it was a different person each time. So no one person got them right away, but different people got them right away because we all think a little bit differently. So what's obvious for me might not be obvious for you. What's obvious for you might not be obvious for me. So sometimes if you struggle with one like this, another one might be easier for you, or vice versa. Okay. But we're gonna try and train ourselves to look for these different patterns. Okay. So we look at what's happening with the numbers. Oh, they're all getting smaller. How do you get smaller? Subtraction or division. Oh, they're all going down by 7. So what do we think the next number is going to be? 10, because we subtract by 7 again. And then what would follow that? Do we think? 3. And then what's 7 less than 3?
-4.
-4. Keep going. 2 more. -11 and -18. Okay. So that's our next 5 terms. We use the pattern to say, hey, we think this is what's going to be the next 5 terms. So our conjecture is the conclusion we reach. So we can say, how do we get the next term? Okay, subtract 7 each time. Does that explain what we did?
Yeah.
I think so. I think that accurately explains what we did. I don't think someone would be confused by that. We say subtract 7 each time. I think that's fairly straightforward. Questions on that? Okay. So this next one, we have 2, 5, 11, 23. Okay. Ian, what are you thinking? Multiply by 2 and add 1. Okay. So 2 times 2 is 4. 4 plus 1 is 5. Okay. So we times 2, add 1. Okay. 5 times 2 is 10. Plus 1 is 11. So times 2 plus 1. 11 times 2 is 22. Plus 1 is
See,
6.
I would have never gotten that.
Me either.
I just thought going up by 3, 6. Well, I just thought
Yeah.
doubling.
Yeah, I saw that too.
What do you think was doubling?
The numbers.
Okay, so you thought the number we added to it was doubling?
So like.
So we added 3, here we added 6, here we added 12,
Yeah.
okay? So according to that, we should add 24. Well, let's look at this. See if they both work. What's 23 times 2? 46 plus 1 is?
47.
What would be 23 plus 24?
47.
47. So it works out either way, okay? And there's actually a good reason why it works out either way. Is because if we're doubling 2, we're really adding 2 more to it, right?
It would
2
be
plus 2,
48.
23 plus 24.
Oh.
I think you do 24 times 2. Okay?
No, I
Oh.
did not.
Okay. So 2 times 2, we're really adding another 2 to it, plus 1, so we're adding 3 to it. 5 times 2, we're really adding another 5, plus 1, so we're adding 6. 11 times 2, we're adding another 11, plus 1, so we're really adding 12. So 47, what's 47 times 2?
90.
94 plus 1 is 95.
191.
Okay, and then it does end up being 191.
I don't know what the next one is.
Okay.
A big number. I can't do quick math. Numbers like that.
82. Or excuse me, 383. Excuse me, not 382.
And then
Wait. Calculating.
742. 741 and a half. That's what I got.
So we double it and then add 1. Double it.
Okay, how did I get-
double it and add 1.
How did I don't understand.
You got
Like, I just can't figure these out.
Well, we're only 2 in. Okay.
I know, but we learned these in like 5th grade, and I
Take
could
a
not
deep
do that.
breath. We're gonna keep practicing.
Alright.
So, let's say our conjecture, how we get to each one, let's say double the previous term, so we know which term we're doubling, and add 1. Double the previous term and add 1. I think that's pretty clear and straightforward now if we say that, so everyone make sure we're writing that in. we say double the previous term, that tells us exactly which term we're doubling. We're not confused about that. If we just say double and add 1, we might not know what we're doubling. So I think this just makes it a little clearer to do that. Okay? Let's look at this third one. 1, 4, 9, 16. 1, 4, 9, and 16. Take a moment to kind of think about that. We can get some practice here.
Okay, yeah, wait 1 second.
I have no clue. No learning, but think about it.
Insert Jeopardy theme here. Square.
Marissa, what are you thinking?
No, I'm not.
Okay. Sorry. Sam,
Okay,
what
but
are you,
they're all different.
Sam, what are you thinking?
It's when I'm on numbers of 3, 5, 7,
Okay. So what do you think the next one would be then?
9.
Okay, so we're going up by odd numbers, okay? And the next odd number, okay, not bad. Okay, does anyone have anything else they got? Anyone get anything else? Mason?
They all involve 8. 1 times 8 is 1. Half of 8 is 4.
Okay. I like that we're thinking outside the box. I like that we're thinking outside the box. Okay. Actually, I hadn't heard this one of adding by the next odd number. Okay. But if we keep that going, we can add by 11.
Wait, you haven't heard that one yet? Seriously, what was the one that you
We'll add by 13. Well, we'll still get it. It'll still work. Add by 15. I'll explain it. Add by 17.
Okay, wait, how do you just?
1.
There you got it.
Okay.
I need
What
this.
I was thinking of was perfect squares.
Oh,
What's 1 squared?
1.
What's 2 squared?
4,
What's 3 squared?
9.
9. What's 4 squared?
16.
And then 5 squared, 6 squared, 7 squared, 8 squared, 9 squared.
Oh, I didn't notice that.
They're all multiples of 9.
Okay, don't. I forgot what you just said.
So,
So how do we figure it out though? Like you guys just.
8.
I don't understand.
Think. Just think
you
about
look at
things.
it and you say, what's happening here? Okay, we're increasing, so we know we're getting bigger. Okay, so we know we can't be subtracting or dividing. We're probably multiplying or adding of some sort. We're getting bigger.
So you're just guessing until it works out.
You're just kind of guessing to see, is this a pattern? No. Is this a pattern? No. Is this a pattern? Oh, 1 to 4, maybe we're adding by 3. Well, no, we're not adding by 3. Okay, we're multiplying by 4. Well, no, we're not multiplying by 4. Okay, let's think of some other stuff. So we're adding by 3, adding by 5, adding by 7, adding by 9. Oh, those are all odd numbers.
Can the blank numbers be different? Like, so if Grace does it a different way, then I do it a totally different way.
If they both make sense for the pattern we've seen so far, then sure. So based upon the first 4, if both of yours make sense, then yeah, I'd accept it. Okay. So conjecture, we could do either one of these. Okay, so we could say add the next odd number add the next odd number. Okay, or I can say a different one, the one I brought up, consecutive perfect squares. And I'd be really okay with either, because they both make sense.
I'm getting this.
I am not.
We'll get there.
I didn't get the last two.
I can get Mr. Cross next. Okay, let's go on to the right below this, okay?
You
Go on right
didn't
below
say
this.
to me. It's fine, but just think for next time.
Hi, Not. I'm Mr. Carlson. Nice to meet you. Yes. You have the next one? Doe, what do you think it is?
So you're going 2 letters up. So B, C will get you D.
Mhm.
E, F will get you G. H, I will get you J. And then the next one will be M. And then P, S, V.
So or skip. Oh, you said what?
Why?
I'll try it one more. Okay. So what's another way we could word that? Okay, I completely agree. Marissa has it right. What's the way
Skipping
we
2
could
letters.
word- Skip 2 letters every time. Okay. Every third letter, skip 2 letters every time. Either one. Okay. So we could say skip 2 letters each time. Or you could say every third letter. Either way, it really means the same thing. You're
Yeah,
skipping
I
2
really
or
want to
skipping
get the
3.
next one. I don't know how to.
So the next one here, 7:30, 7:55, 8:20.
Add 25 minutes.
Add 25 minutes each time.
Air 5.
And Matt, you got it. Okay, next time raise your hand, okay? So we're gonna add 25 minutes each
You
time.
just had to ruin my moment.
Yes. Add 20. I first said good job, and I'm happy for you. Okay. Add 25 minutes each time. So what would be the next one following 8:20? 8:45. Very good. 9:10. 9:35. 10:05, but 10. And then 10:25. Okay. And we're actually going to skip number 6. I really don't like it at all.
Wait, what do you do?
I don't think there's a good pattern. I don't like it at all. We're skipping it.
I know the
Or psychology.
So there's that. I like that pattern, but there's not a really good way to describe it.
Yeah, I know.
So
I
we're
Kind
skipping
of figured
that.
out just add the 1 in front of the number, so 3 plus 1 equals 4, 4 plus 1 equals 5, 5 plus 1 equals 6.
You're making me confused.
Okay, we're gonna go on to the next page, okay? Hey, this is our only other page in notes today. After we do this page, we're done for notes today. Okay?
What?
Real talk, and then you have time to look at homework.
Can we work on other things?
Yes. Okay? You could work on by other things and specifically test corrections. I wanna
Watch,
make sure
this
other
thing is
things
gonna
for this
take
class.
us 45 minutes.
You want me to? I can make it take long.
Oh,
It's
yeah.
way too long.
Get shut down.
Okay, so, hey Ian.
Oh.
That's a you boy. Just general. You're always thinking well. That's the way Ian does it. Anyway.
I'm a god.
Counter example. Does counter mean for or against?
Against.
Against, okay? So, it's an example that proves a conjecture is false. It's an example that proves a conjecture is false.
Okay, wait, how'd you learn this? Did you learn this Oh,
It's an example that proves a conjecture is false, okay? We're saying that either a conjecture is always 100% of the time true, or it's false. So to prove it false, we only need one instance where it's not true. To prove it false, we only need one instance where it's not true, okay? So we're saying we're going to determine whether these conjectures are true or false, and if they're false, we're going to provide the counterexample, okay? So number 1, the sum of any 2 consecutive integers is always odd.
no.
Okay, let's break this down a bit. Okay, sum. What's sum mean? Adding. Okay, we're adding. And what are we adding? 2 consecutive integers. What's that mean? What's consecutive mean?
Right after the other. 2 numbers right after each other.
Right after each other, right? They follow each other. Okay. So what are 2 integers like? The integers like -1, 0, 1, 2, 3. So what are 2 integers, Ian? 2 and 3. Okay. So we're saying the sum of 2 integers is always odd. 2 plus 3 is 5. Is that odd? Okay, somebody give me 2 other consecutive integers. Let's keep trying this out. 20 and 21. That ends up being 41. Is 41 odd?
No.
Yeah.
Yes.
Yeah, okay. Let's try some different ones. Maybe 0 and 1. Do we still get an odd one?
Yeah.
0, -1.
Let's try 0 and -1. Is -1 odd?
Yeah.
So far, looks like it's true. -2 plus -3. -5, is that odd?
I really want it to be wrong.
Okay, so is there a single time that you guys can think of when this is false?
No.
I don't.
Pi.
So it's true. But pi is not an integer though. That's a great idea. Pi is not an integer. So integers have no decimals or fractions.
Oh, so literally anything.
Any number.
No.
Any whole number that's also
Sir,
negative.
I thought it was
Five
like the thing
should-
where you're like, if not the sum of any two
Well,
consecutive.
We'll be doing that. That's called a conditional statement.
Oh, that's what I thought it was.
Yeah.
Never mind.
So I like to go through some examples and start testing it out. That's how we know whether it's true or false. Is we
That's
test it.
some crazy numbers to add together.
Okay. Yeah. The product of two numbers is always larger than either number. The product of two numbers is always larger than either number. What's product mean?
The total, right?
False.
It means multiplication of any two numbers this time. They don't have to be consecutive integers. Is larger than either number, or larger than both numbers is the way you can word that. Grace, what are you thinking?
Can I say that answer?
What are
I
you
don't
thinking?
think it is because 0 times 1 is 0.
Is 0 bigger than 0 and 1?
No.
No, so we already found a counterexample. And so just because we have at least one time when it's wrong, it's false. If we even have one time when it's wrong, it's false. Okay? Now, 5 times 2, that's true because it's 10. But here, it's false. So it's
Oh.
false.
So like 1 times 1. So like
1 times 1, anything times 1 is.
can you like is this good for like
Let's try that. -5 times -5. Positive, is that bigger than those two?
Yeah.
Okay, what about a negative times a positive? -5 times 5. Is -25 larger than those two? No, so that's false too. So this is false. Anytime you multiply by 1 is false. Multiply by 0 is false. I love that we're thinking this way. This is awesome. Okay? So for a counterexample, you truly only need one counterexample. If you're wrong once, it's wrong. The product of two perfect squares is always a perfect square. Product means what again?
Like multiplication.
Multiplication, okay? Perfect squares. Somebody give me a perfect square. 2. Not a perfect square. 4. 2 times 2 is 4, so 4 is a perfect square. Somebody give me another perfect square.
No.
5.
Okay, 9. I heard 9. Okay, 3 times 3 is 9. A perfect square is where two of the same number
16.
multiply to get it. 16 is 1, 25, 36, okay? We're saying the product of two perfect squares is always a perfect square. 4 times 9 is 36. Is 36 a perfect square?
Yes.
6 times 6, okay? Somebody give me another two perfect squares, just random ones.
25 and 30.
25 and 16. Okay, you're gonna stretch me a bit here.
You should know that off the top of your head.
Probably. Oof.
I don't know about the top of my head.
400. 400 is 20 times 20.
Does it have to be two different perfect squares or the same?
The product of any two perfect squares. So 25 times 16 would be
4
different.
times, no, it's false.
36 times 36.
4 times 4 isn't a perfect square.
4 times 4 is what?
8.
16.
Oh!
Okay. And hey, let's think about it this way. If you multiply 36 times 36 or 4 times 4, well, the answer is going to be whatever 36 times 36 is. So is that already a square?
Yeah.
Because they're multiplying two of the same number. Okay? And you guys could give me like any two numbers, and this will honestly work. Like somebody last class gave me 49 times 36, and it still ends up being a perfect square. Okay? So this one is actually true. You can do it with any two perfect squares, and you will always get a perfect square. I think so. I think math is fun. Casey's agreeing with me right now.
Boring.
I see the smile on her face. Math is fun, right?
No.
Oh,
I have
That's
to
her
agree with Casey half and half. I like
rude.
all math, but this kind of
Discipline.
math.
If the area, what?
Just say
Oh,
you
hey, well,
understand it.
we're reading right now. Oh. If the area of a rectangle is 6 square meters, then the dimensions must be 2 meters by 3 meters. Okay? Well, how do we get area of a rectangle? Does anyone know?
Like length times width times height.
Length times width. Times height would be a shared volume, volume of a cube, if I can speak. Okay? Area is equal to length times width. Okay? So we'd be taking
Fine.
2 times 3. So that's 6. Okay? So So we're saying if the area of a rectangle is 6 square meters, the length has to be 2 and the width has to be 3, or vice versa. Is that true?
That makes no sense to me.
Okay, we're saying that for the area of a rectangle to be 6 square meters, okay,
Yes.
that the dimensions have to be 2 by 3. One side has to be 2, another side has to be 3, for that to be true.
Yeah.
Is that true?
Yes.
Could we multiply any two other numbers together and get 6?
Yeah.
What?
6 and 1. Yeah. 6 and 1.
So, do the dimensions have to be 2 by 3? No, it could be 1 by 6. So this is false. And our tiny rectangle.
False.
And our counter example
Use
is
the triangle.
1 times 6. Hey, a rectangle is secretly 2 triangles though, fun fact.
You did not know that.
Yes, I did. You put 2 triangles together.
You did not know that before you said it. Don't lie to yourself.
Ian trying to give everyone
And a
the
trapezoid is just 3 triangles.
5. Dividing by 2, dividing by 2 always produces a number less than the original number. Dividing by 2 always produces a number less than the original number.
Yes. Yes, true.
Brayden, give me a number.
68.
68 divided by 2, that ends up being 39, excuse me, 34. That's less, okay? Grayson, what are you thinking?
Negatives.
Negative. What's negative 8 divided by 2?
That's positive 4. No. I just had really bad deja vu. Like turning around and look like that was so weird. Why did I think? Why? Oh my god. It was so weird.
So if we try a negative, Grayson was saying let's try a negative, okay? Let's try negative 8 divided by 2. That ends up being negative 4. Is negative 4 less than negative 8?
Yes.
No.
No.
Bigger. Because negatives, remember? Negatives are backwards, okay? So, dividing by 2 always produces a number less than the original number. Is negative 4 less than negative 8? No. So this is false.
This is a neat looking poster you have here.
It is. Thanks.
Where'd you get it at?
I found it on the ground.
Really?
What is it?
Minnesota Vikings one.
The joke is I got it for him when I was in Minnesota watching the Vikings game.
It's true. Like that?
Y'all have huge beards. Nice. Beards. Huge musky
Weird flex, but okay.
Good time to use that.
He was gonna say it.
beards. You can go on.
So, vertical angles are never complementary angles. Vertical angles. Which angles are those? They make an,
Equal pair.
okay?
X.
They make an X, okay? They make an X. So vertical angles are the angles that make an X. Okay? So like this and this with the 2 arcs, those would be a pair of vertical angles. And what do we know about vertical angles? They are always congruent.
Oh my
So
god.
that means they're the same measure, right?
Yes.
Okay? So we're saying vertical angles are never complementary angles. What's it mean to be complementary?
They complement 90.
They add up to 90. Look at my complementary angles poster. Remember, they add up to 90 and they're complement each other. How nice, okay? So we're saying vertical angles, angles that are congruent, can never add up to 90. Is that true?
No.
That makes
They would just
False.
It's false because you can have 45 and 45.
Yeah, false. Because they could be both 45 degrees.
They could both.
They could both be 45 degrees. So if this is 45 degrees, and this is 45 degrees, does that add to 90? Yeah, so then they would be complementary. Our next one here, if A times B equals 0, if 2 numbers multiplied equals 0, then A equals 0 or B equals 0. We're saying if 2 numbers multiplied equals 0, then at least one of them is 0.
Yeah.
Yeah, false. That's true. And if that's false, when is it false?
if 2 numbers add together equal 0, one of them has to be 0.
Not add, multiply.
Oh, never mind.
So like 5 times 0, always 0, right? 1,284.3 times 0? 0. Okay. Let's just do number 8, and then we'll be done with our notes. Okay.
Yes.
Two angles supplementary to the same angle must be congruent. Okay, dealing with two angles right away. Supplementary means what?
Equal 180.
Okay, add up to 180, okay? Complementary is adding up to 90, this is adding up to 180, okay? So two angles are supplementary to the same third angle. Let's start off with two angles, we don't know them. Angle X and angle Y, okay? Let's say they're both supplementary, adding up to 180 with another angle that we have as 120 degrees. So these two angles, X and Y, are both supplementary to 120. So what plus 120 will get 180 for X? 60. Okay? Now if Y is also supplementary with 120, what's Y have to be? 60. Are these two angles the same? Yeah. Is it possible for them to both add with this to 180 if they're different?
Yes.
Okay? No. Because 120 plus how many other numbers will equal 180? Just one. Like 5, for example, 5 plus how many numbers will get 7?
2.
Okay? 5 plus 2, but how many different numbers are there? Just one. Just one option for it. You can't add a different number other than 2, and get 7. So you can't add another number other than what we're already adding and get to it. So two angles that are supplementary to the same angle have to be congruent. That is true. We're saying that one is true, okay?
All stadiums have at least 2 syllables.
Mr. Carlson, I made fun.
Oh, cute. Okay.
Oh, I have to talk to you after.
Okay. Hey, so today, we have this worksheet here. It's pink. Okay, it's pink worksheet. Okay.
Did you watch the lip sync?
Okay.
Did you see the sophomore one?
That's all.
Did you see me dancing to Mean Girls?
I saw you do this. Yeah, I did. Oh, I caught that right away. I'm like, oh, Mean Girls. Guess what?
Whose was better, juniors or sophomores?
I think juniors are the best.
Only the juniors because Xander.
I'm not gonna lie.
It was not.
Yeah.
Juniors were, you guys,
Juniors
they
were-
ran out of time on the music. It wasn't orchestrated at all.
Juniors were- All of a sudden, you go.
Yeah.
Hey, on this worksheet, okay, the front of this worksheet is like the first page of our notes. The back of the worksheet, second page of the notes.
Good.
Okay? You guys have 20 minutes to work on this. That's some good time here, okay? I think it's possible that a few of you might even be able to finish, okay? Which is awesome, okay? You guys can listen to music while you work on this. Feel free to do that. Just don't let your phone be a distraction.
This is a two-page document.
Gracie.
This is a two-page document, okay?
What does that mean?
Okay? So I want you to work individually, though.
I know, we can sit back there and just work individually. Yeah.
It's your console. I know. It's your console. Do you play Clash Royale? You need to download it. Is everyone
Look, I
playing
made
it
a
now?
flower.
It's popping off.
Not as good as me though.
You got a hole in your leg.
Ow, I know. I never go to sew it. Can you